Okay, so we're in 4.1 and we're going to be doing numbers 2 and 3 from Ready, Set, Go. It says describe the transformation of each function from f of x equals x squared, then write the equation of the function. So this is a pretty standard question that Ms. Johnson will ask because graphing is really, really easy now that you guys get to use Desmos, right? So they basically want to know your original x squared, which is like right here-ish, like pretend I'm good at drawing, right? It kind of looks like, I don't know, something. You see my little parabola. And then he moved down, right? He moved down this way. So the first thing I noticed is he moved down, right? So I would write something along the lines of, what should I say? Shift down, how many? 5 units. And you can say translate, you can use the word translate down 5 units. Shift is fine too. And this translate down 5 units will show itself up in the equation, right? This will show up here. The other thing that I kind of noticed too is he got a little skinnier. And if you remember about skinnier, it's that A term. So we call that in normal term a vertical stretch of, and then I don't know what the vertical stretch is because I haven't played with my numbers. So it looks like instead of this, so when I move over to the right one, it went up 2. And normally when I plug in 1, I get 1, right? 1 squared is 1. So, but here it moved up 2. So this is probably a vertical stretch of 2. And I'm going to put a little question mark until I know for a fact. Okay. And I'm going to use my function, the function that I write to make sure that that's true. So does anybody remember how do I show in the equation shift down 5? So your generic equation is going to look like x squared, right? If I shift him down 5 units, what is that? Yeah, it means -5. Very good. So here's our equation. It looks like this, x squared minus 5, right? That's the first guy. And then I know there's a vertical stretch and I think it's 2, but I'm not sure. So the way I figure it out is I plug in 1 and I want to get out -3, right? I'm going to plug in 1. I'm going to plug in 1 and I want to get out -3. Right? So here I go. I'm like 1 squared minus 5. Well, that's 1 minus 5. Oh no, that's -4. That's not correct. But then I said, hey, I think it's a vertical stretch of 2, right? So the one way that I could do this is I can pretend that there's this A that I need to find. Oh, this is not catching up very quickly. Hold on a second. Let's see. There it goes. So there one way to do this, I'm pretending that I didn't know this A was here, so just pretend that he's not there. So I plugged him in and I got 1 minus 5, that's -4, boo, right? So now I'm going to plug in this A. I'm going to set it equal to -3 because that's what I want to, like, I want to find what that's equal to. So I'm going to cross out this work. So now I get A minus 5 equals -3. And if you solve that, you get A equals 2, which means that's 2, and I was right. Right? It means that I was right. That is a vertical stretch of 2. Okay, let's see if this guy can catch up a little bit faster. Oops. Okay, so there's going to be a 2 right there. Yeah, so when you solve this, you get 2, and so now I have a 2 there. So my function is 2x squared minus 5. Just for fun and for checking sake, I would check one more point, which looks like it's right there. If I plug in 2, I should get out 3. So when I plug in 2, I get 2 squared is 4. 4 times 2 is 8. 8 minus 5 is 3. Yay! So that's basically what you're doing. You're just paying attention to the shifts and the stretches. Always, always, always check at least 2 points. At least 2 points when you're dealing with like functions like this. Okay. Number 3. So number 3 looks like it's being shifted, right? So normally my little guy, my original guy looks like this, right? Oops. And he looks like, so I don't know, right? Looks like that. So if I scoot him over, it kind of looks really good. Like I don't think there's a vertical stretch for this one. That's what my gut is kind of telling me. Yeah, and it just looks like it's left 3 units. So left 3 units here. What does that mean in terms of our equation? In terms of our equation, yeah, in terms of our equation, it would look like this: x plus 3. Very good. You remember that x lives in backwards land. Someone asked a question about the last one. Let me pull that up. It says, wait, would -5 be for x? Yeah. So this would be a -5. Yes. And then I think you're asking over here, this would be left 3. So that's why it's +3. Very good. And that's pretty much it. Again, I would check a couple points just to make sure. It looks like a good point to check is -2, 1. So when I plug -2 in, I get -2 plus 3 is 1. 1 squared is 1. So yay. Another point I can plug in is -1, 4. So when I plug in -1, I get 2 squared is 4. So yay. Yeah. So perfect. That's just a really quick reminder on how to use your translations, your shifts to write your equations. Again, double check with your points. Otherwise, you can kind of be tricking yourself. So very good.